For section 2.8, equations with infinite and no solutions, we're going to solve equations that have multiple steps, but these equations are going to have no solutions, or they might have infinite solutions. So we're taking our previous knowledge of solving equations where we would solve it down and we would get a single solution like x equals 0, and we're going to take that another step further. So instead of getting that single solution, there's either going to be no options, no values of x that you can plug into the equation to get the two sides of the equation equal, or there's going to be infinite solutions, which would be where you can plug in any number in the entire world for that variable, and both sides of that equation are going to be equal. So we're reasoning abstractly and quantitatively today. We're taking our knowledge of numbers and we're taking it another step further. We're thinking a little bit more outside the box with these. So our typical situation when we solve an equation is to get one solution. We just get x equals something. But sometimes there are two different special situations that might occur. These two situations are sometimes equations have infinite solutions, and sometimes they have no solutions. So these are two different situations. However, in both of these situations, in both of these cases, there's going to be one common trait. There's something that they have in common. And that's that the variables cancel out on both sides. So on both sides of the equal sign, your variable is going to cancel out. So as you're going through and you're solving, when you cancel out the variable on one side to move it over to the left side, it's going to end up canceling the variable out on the other side also. So then what is that going to leave us with? Well, if all of our variables are gone, we're just going to be left with some numbers. And so this is where we get the two situations. One common thing happens, our variable goes away, and then we're left with two possibilities. Our first possibility is that we have a true statement. We have a statement like 5 equals 5. Well, that's something that's always true. No matter what, no matter where, no matter when, that's always going to be true. If that's the case, then we're going to have infinite solutions. So infinite solutions would be, I can take any number in the world, as I said before, I can plug it in for my variable to my original equation, and both sides of that equal sign are always going to work out. So if you think through checking equations that we've done in the past, no matter what number you put in there, it's always going to be equal. Versus in the past, we have one specific number that makes it equal, and if we try any other number, it doesn't work. So going back, we have that one common trait that our variables cancel out on both sides. And if that happens, we might get a true statement like 5 equals 5, or we'll get a false statement. That would be like 3 equals 7. So if we get something like 3 equals 7, that's never true, no matter what. So there's going to be no solutions. If this is the case, it doesn't matter what number I choose. Any number in the world, I can plug it in for the variable into the equation, and it's never going to work. I'm never going to have both sides of that equal sign equal to each other. So let's go ahead and do some examples and see what this actually looks like. Looking at example 1, this looks like just a regular problem. This looks like a multi-step equation that we've been working on. So let's go ahead and go through the steps. My first step is to distribute on both sides. So I'm going to distribute the -3. Make sure you distribute the negative to both parts of the parenthesis. So I'm going to distribute it to the -2r to get positive 6r. And then I'm also going to distribute the negative to that 3. You're always looking at the sign in front, so I have negative 3 times positive 3, which is negative 9. On the other side of the equal sign, I have a 6 that I distribute into the parentheses. So I get 6r, and then I get 6 times negative 2, because I'm always looking at the sign in front, and that's negative 12. So moving on to my next step, when I'm solving equations, I'm always going to combine like terms next. So if I'm looking just on the left side of this equation, I don't have any terms to combine. And then if I look at the right side, I also don't have any terms to combine. So I'm going to go on to my next step, which is move all variables to the left side by using the opposite operation. So on the right, I have a 6r. And so to move that to the left side, I need to subtract it. I'm going to do the opposite of a positive, which is a negative. So now as I'm rewriting my equation, on the left, I have 6r minus 6r, which is 0. Those cancel out. And then I get negative 9. On the right side, my 6r's cancel out, and I have negative 12. This looks kind of weird. Although at this point you might think that you've done something wrong just because this looks kind of different, you haven't. This is perfectly fine. This is the right answer here, but this is not what you're going to leave your answer as. Your answer is not negative 9 equals negative 12. You need to tell me what that means. So if we look back up into our box, we see that negative 9 equals negative 12 is a false statement. And so we're looking at this part right here. When we have a false statement, then there's no solutions to the equation. So my answer here is no solutions. So once again, that means that there's not a single number that I can plug into my r's to make this equation true. So the next part of solving equations is always to check them. But how do we check something if there's no solutions? There's actually, you can't. The only option is to plug in numbers. But you're never going to have the same thing on both sides of the equal sign. So in our little thought bubble here, we're going to write that we're not going to check no solutions, just because it's kind of useless. We can't check them thoroughly, so we're just not going to do it. So I'm going to say, nope, no check. All right, moving on to my next example. I have another problem here that looks just like any other problem. So I'm going to first distribute. I need to make sure I distribute the negative along with the 2. So I have negative 2 times 3k, which is negative 6k. And then negative 2 times positive 2, which is negative 4. And I still have that plus 10. I need to distribute that negative 6 now. So that's equal to negative 6k. And then negative 6 times negative 1, because you're always looking at the sign in front, makes a positive 6. My next step is to combine like terms. So on the left side, I have a negative 4 plus 10 that I can combine. And that makes 6. So I have negative 6k plus 6. And on the right side, I do not have anything to combine, so I'm just going to rewrite it. Now I'm going to pause and just notice at this moment that the left side says the exact same thing that the right side does. So let's continue working this out and let's see what happens to this equation. I'm going to add 6k because I have a negative 6k that I want to move to the left side of this equation. When I do that, my 6k's cancel out and I'm left with 6 on the left side. My 6k's cancel out on the right side and I'm left with 6 as well over there. So I have 6 equals 6. If you look back up into your box, that is a true statement. So that means that this has infinite solutions. So this means that no matter what number I choose to plug in for k, the left side of this equation is always going to equal the right side. So we can actually check this one. What we're going to do is you can choose any number. Since any number is going to work, you can choose any number in the entire world and plug it in for that variable, and the left side is going to be equal to the right. So in our little thought bubble, we're going to write choose any number for the variable and check for infinite solutions. This is always going to work. If it is indeed infinite solutions, it's always going to work. So let's go down here and try this. So before we check, we have to think, what number do I need to plug in for my variable? So like I said, you can choose any one. So you can sit here and do this check on your own and choose your own number. I always like to choose 0, just because 0 is a simple number to work with. Numbers tend to cancel out faster, and I just have smaller numbers when I'm working with 0. So that's what I'm going to do. So I'm going to rewrite this, but in place of the variable, I'm going to put 0. So I'm going to zoom on this. I'm going to work through the left side first, and then I'll work through the right side. Once again, I'm just doing order of operations when I'm checking this. So when I'm looking at this, I need to do the parentheses first. And inside of the parentheses, I still need to follow order of operations. So I need to do the multiplication. 3 times 0 is 0. And then I'm gonna just rewrite everything else on the left side. I'm still inside the parentheses. I have 0 plus 2, which is 2. I'm rewriting. Now I need to do multiplication. Negative 2 times 2 is negative 4. And negative 4 plus 10 is a positive 6. Now going over and working on the right side of this equation, I need to work in the parentheses first. 0 minus 1 is negative 1. And now I just have multiplication left. Negative 6 times negative 1 is a positive 6. So those two are equal, which means that for 0, this works. Now you could take some time and try some other numbers if you wanted to, but all that I'm going to require is that you choose just one number. It can be any number, and you check it with that number. Let's go ahead and work through this last problem together. So this last problem, once again, looks like just a regular multi-step equation, so I'm going to work through it. And I'm just going to keep working until I get to a point where I have nothing else to do. So I'm first going to distribute. So I get negative 12c plus 16 plus 7. And then I need to make sure to distribute that negative to every part of the parenthesis. So that's negative 2c minus 7 minus 5c. Next, I'm going to combine like terms. So on the left side, I have 16 plus 7, which is 23. So I get negative 12c plus 23 equals. On the right side, I have a negative 2c and a negative 5c, because you're always looking at the sign in front. Negative 2c plus negative 5c is negative 7c. And then you have that minus 7 there still. So at this point, you might notice that the variables have different coefficients. And so they're probably not going to cancel out. Let's go ahead and just keep working through this and see what happens. I need to move my variables to the left side now. So I have a negative 7c at the right on the right side. The opposite operation of that is plus. So I'm going to add 7c to both sides. Negative 12c plus 7c is negative 5c. So my variables did not cancel out, so we'll just keep working through this until we have a stopping point. And then I have plus 23 equals negative 7. My next step, I need to subtract the 23. I just have a two-step equation at this point. So I have negative 5c, my 23's cancel out, is equal to negative 30, because negative 7 minus 23, or negative 7 plus a negative 23 is negative 30. And then I need to divide by negative 5, and I get c is equal to positive 6, because a negative divided by a negative is a positive. So I got a single solution here. This is just a regular multi-step equation. So I'm going to go ahead and check this solution. I'm just going to plug 6 in for c. So I have 4 times negative 3 times 6 plus 4 plus 7 equals negative 2 times 6 plus 7 minus 5 times 6. I'm going to work through the left side first, and then I'll work through the right. So working through the left side, I need to work inside my parentheses, and inside the parentheses I need to do multiplication because that comes first with order of operations. Negative 3 times 6 is negative 18, and I'm going to copy everything else down. I'm being very careful that I'm copying it correctly. I'm still inside the parentheses. I have negative 18 plus 4, which is negative 14, and I'm copying everything else down. 4 times negative 14 is negative 56, and negative 56 plus 7 is negative 49. Now I'm going to move over to the other side of this equation, and I'm going to work through order of operations as well. So inside my parentheses, I need to do multiplication. 2 times 6 is 12, and then I'm copying everything else down. Make sure you copy down that negative that's in front of this whole thing. Inside the parentheses, I still have I have 12 plus 7, which is 19. I have that negative in front. Next, I have multiplication. 5 times 6 is 30, so I have negative 19 minus 30. I'm going to add the opposite. Negative 19 plus 30 is negative 49. So these two are equal. So 6 is a correct solution to this problem. So right here we have all 3 possibilities that you will ever have this year for this class when you're solving an equation. This last example that we did is an example of one solution. That's what we're used to. That's just where you solve it down and you get one number that the variable is equal to. The second one that we had done was infinite solutions. So that's when you solve it down, your variables cancel out, and you end up with a true statement like 6 equals 6. That's going to be infinite solutions, and you can check that. You just get to choose what number you plug in to the equation to check. The first one that we had done was no solutions, so that's where you work it out. Your variables cancel out, and you're left with a false statement like negative 9 equals negative 12. That's not true, so there's no solutions, and you don't even have to do a check for that one. You are good to go to complete your homework over this section now. If you still have questions off of this, definitely feel free to let me know.